So what I have for you is there's going to be a PDF. I'll put this in Schoology as well, attached underneath this video. I'm going to do the odd numbered problems with you. I want you to try the even numbered problems tonight for homework. Okay, so I'll do the first few with you, and then I want you to try the other ones. So what we're looking at here is, and we're actually going to start with some word problems instead of starting with equations, because what I want you to be able to do is write the equation as the story is being told and then undo the equation. Okay, so our story is, I think of a number, let's call it x, and when I think of that number, I'm going to add 3 and then multiply by 2, and the answer is 20. So here's what my equation should look like. I'm thinking of a number, I'll call it x. I'm going to add 3, and then I'm going to multiply that result by 2. Well, if I'm multiplying that whole result, that means I need parentheses there, by 2, and the answer is 20. Okay, see if you can make that make sense in your mind. So I thought of a number, I added 3, I then multiplied that by 2, and the answer is 20. So now what we're going to do is we're going to undo those operations in reverse order. So I'm going to undo the multiply by 2 part using inverse operations. And the inverse of multiply by 2, you know that's divide by 2. So in algebra, when I divide by 2, instead of a little divided by sign, I'm going to think of it as a fraction, okay? So I'm going to divide by 2, and whatever I do on one side of the equation, I also need to do on the other side. Now, sometimes what I'll do here is draw a line, like a river, through that equal sign to remind myself that whatever I do on one side of the equal sign, I also need to do on the other side. So I divided the left side by 2. Now I'm going to divide the right side by 2. And the reason I did that is because now I had this thing multiplied by 2, and then I divided it by 2. That means the 2 is gone. That makes a factor of 1. That's our multiplicative identity. We pulled it out again. Now I've got on the left-hand side of that equation, I have x plus 3. And on the right-hand side of the equation, I have 20 divided by 2, which is 10. So I simplify each step as I go. All right, now I'm going to go back and look at that story again. The story said, add 3, then multiply by 2. So I've undone the multiply by 2. Now let's undo the add 3. And again, the inverse operation. Inverse of add 3 would be subtract 3. I subtract 3 here, and I subtract 3 here, and I get x. Minus 3 plus 3, that cancels out, right? That's called an additive identity. They add to 0, and x equals 10 minus 3, which is 7. Okay, so we're going to write the story, and then we're going to undo that story in reverse direction. We're going to write the equation and then undo those steps in reverse order. Okay, so let's do number 3. Number 3 said I'm going to think of a number. I'll call it x again. I'm going to divide it by 2. And again, in algebra, we don't usually use the division symbol. We use a fraction bar. Divided by 2. And then add 8. And the answer is 14. Here's a little hint in an algebra problem. Whenever we use that verb, that's where our equal sign goes. So now I'm going to undo that story in reverse order. We're going to undo what happened to x in reverse order. So the last thing that happened to x was that we added 8. So the inverse of adding 8 would be to subtract 8. Once on the left side of that equal sign and once on the right side of that equal sign. Draw a big equals bar here. Now I'm going to bring down what I had written up above that I still need. I still need that x over 2. Minus 8 plus 8, that's gone now, equals 14 minus 8 is 6. So I've undone the add 8. Now I'm going to undo the divided by 2. Well, the inverse of divided by 2 would be times 2. So I'm going to multiply both sides of that equation by 2. And when I do multiply, I'm going to do a little dot, times 2 on this side, and times 2 on this side. And again, the reason is now I've got x divided by 2 times 2. Well, divided by 2 and times 2, those wipe each other out. That becomes 1. And I have 1x, or just x, same thing, equals, and 6 times 2 is 12. Now what I can do here is I can go back to the original equation and check to make sure I have the right answer here. If I put in 12 for x, or if I go up here, if I take 12 and divide it by 2, and then add 8, I should get 14. Let's see, 12 divided by 2 is 6. And then if I add the 8, I get 14. So I know my answer's right before I'm even done with the problem. Okay, let's look at number 5. Same thing, I'm taking a number, let's call it n this time for fun. And I'm going to add 17 and then multiply that result. So because it's multiplying the sum, I need parentheses in there, multiply by 3, and the answer is 60. Okay, so let's undo these steps in reverse order. So the last thing that happened here was I multiplied by 3, and the inverse of multiply by 3 would be divide by 3. So I'm going to draw a divided by fraction bar, divide by 3 on that side, divide by 3 on this side. And again, I can draw that little river down here. N plus 17, if I take that thing and I multiply it by 3 and then divide it by 3, that becomes 1. And what I'm left with here is n plus 17 equals, and 60 divided by 3 is 20. Now I've undone the multiply by 3. I'm going to undo the add 17 by subtracting 17 from both sides. And I get n equals 3. 3 is my answer. So my number 3, if I add 17 and then multiply by 3, I do get 60. So that is the correct answer. Okay, let's look at number 7 here. I've got an even longer equation. It says I'm going to think of a number, so I'll call it x. I'm going to multiply it by 2, so 2x. Then I'm going to add 4. Then I'm going to take that whole thing and divide by 7, and the answer is 2. So now I've got 3 steps. We're getting longer here. So let's see. If I go in reverse order, the last thing I did here was to divide by 7, sorry. So what I'm going to do is invert that. The inverse of divided by 7 is times 7. I'm going to write times 7 times 7. And again, this thing, grouped together with that fraction bar, is now divided by 7 times 7. That's just times 1. So this side becomes 2x plus 4. And on the right, I have 7 times 2 is 14. So I've undone the divided by 7. Now I'm going to undo the plus 4, and the inverse of plus 4 is minus 4. I get 2x minus 4 plus 4. Those cancel out. They go to 0. Equals, and 14 minus 4 is 10. Now I'm going to undo the multiply by 2 by dividing by 2. 2 divided by 2 just leaves me with x, and on the right I have 5. X equals 5. Now notice each step down made this a smaller problem. It looks like a piece of pizza or an ice cream cone. Every step should make the line above it smaller and easier. All right, everybody, we have combined like terms. We've worked on our number sense. We've worked on a lot of things in the last few weeks. It's prepped us for one of the big ideas of algebra, which is solving equations. So we're going to start that today. We're going to spend a lot of time on solving simple linear equations. And we're going to use the idea of inverse operations to solve these equations. Now, when we do this, we're going to do something I like to call the story of x. So we're going to think about what's happening to that variable kind of as a story. There's action things, there's verbs happening to the variable in our equation, and what we want to do is undo that story kind of from the back to the front. So we take a simple equation and we undo it with particular steps in the reverse direction, reverse order, to figure out the value of x. So this is going to seem maybe a little goofy today, But in the long run, it helps us to get better at solving equations, which is what our goal is for today.